Welcome to PERT Test Taking Strategies Real Math. So this video is going to focus on the couple of questions that I don't have a cheat or trick to, that you're actually going to have to do some real math. So let's start with the first one. Express 7/8 as a decimal. So whenever you see this question on the test, some kids just think about turning a knob, and when you turn a knob, you twist it to the right. So think about twisting this problem to the right, and that lets you know that that 8 is going to go in front of the division sign. So it would be 8 divided by 7, and we know that 8 doesn't go into 7, so we have to add a decimal and a 0, and since we added a decimal down here, we have to add one at the top. And now we're going to say how many times does 8 go into 70? And if you do not know your multiplication facts, this is where I talk about the dot game. And you don't have a calculator on the PERT on some questions. So the dot game, you would give yourself 8 dots, and you're going to count through them. Every time you count through them, you are going to write that number down. So the first one would obviously be 8. So we would write that number down of 8, and then count through them again, and we would get 9, 10, 11, 12, 13, 14, 15, 16. So you want to write down the number 16. And then count through them again, 17, 18, 19, 20, 21, 22, 23, 24. Write that number down, and then keep counting through all the way, and you will get all of the multiples of 8. And the reason why this is beneficial is because maybe somewhere else on the test, you will have to recall what the multiplication of, or what the multiples of 8 are. So I went all the way up until 72. I don't need to go beyond 72 because that's more than 70. So 8 goes into 70 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to put an 8 at the very top of this, and I'm going to multiply 8 times 8 and get 64. Subtract those, and I get 10 minus 4, which is just 6. And I don't have a 0, which I want to keep having that 0, so I have to add another 0 up here, bring that 0 down. 8 goes into 60. Well, if you look over here at my multiplication facts that I just so happened to write down, 64 is too much, so it's going to be 56, which would be 7 times. So 8 goes into 60, 7 complete times. I'm going to do 7 times 8 and get 56. Subtract 60 minus 56, and I get 4. I need another 0. Bring him down, and 8 goes into 40. Well, that's an actual number on my numbers, on my multiplication facts, and it goes into it 5 times. So therefore, 5 times 8 is 40. I get that 0 at the very bottom, which makes me happy, and my answer would be B. Looking at this one says simplify the expression. So I'm going to focus in on those numbers first. If I have 9 over 12, I know 3 goes into both of those, so I'm going to divide the top and the bottom both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So I know my answer is going to be 3/4. And yeah, based on that alone, it looks like the answer is going to be B. But let's talk about those x's. If I have x to the 5th, that is really the same thing as x times x times x times x times x. There's 5 x's there. And I know that because of the simple example, if you had 2 to the 3rd power, that's the same thing as 2 times 2 times 2. So same concept here, except we're dealing with x's. And on the denominator, I have x squared. So that would be the same thing as x times x. And one of your elementary school teachers taught you if you have the same thing on the top and the bottom, you get to cancel those out. And when I do that, I have x times x times x left over, which the lazy way of writing that is x to the 3rd power. So my answer would have been 3/4 from the number and then x to the 3rd power. Another way of working with exponents, if you want to try to remember this rule, is if we are subtracting, then we are going to, if we are dividing, then we are going to subtract those exponents. So since we are dividing here, x to the 5th divided by x to the 2nd, we're going to subtract, and that would be x to the 3rd. If you are multiplying exponents, so for example, if we have x to the 5th times x to the 2nd, then we're actually going to add those, and that would be x to the 7th. And you can see that just by looking down here. X to the fifth, there's 5 x's. X to the second, there's 2 more. If we're multiplying them, that means we're collecting them all together, so we would have a total of 7. Okay, looking at the other side of this paper, you've got 2 extra problems that if you would like to, you could pause the video right now and try those problems out. Okay, if you did try them, hopefully you got B, 2.25, and for number 2, and for number 4, you would have gotten 9/7 V. Okay, on this page is more real math. Let's look at this first one. It says solve for y. So whenever you have to solve for y, not solve for x now. Don't get that confused with the solve for x's that are on another video. You know that this isn't a plug and chug because look at this term right here, this expression, this part of the equation. It says y equals all of that. You're not going to want to plug that into y, so that's how you know that recognize this is not a plug and chug problem, but an actual real math problem. All right, so let's start off with writing it down. X plus 7y equals 21. If I am solving for y, then that means I need to get y alone. Everything else needs to move over first, and then that y can move over. So I'm going to put my wall, and I'm going to move things from one side to the other. Whenever I move something from one side to the other, you need to remember to always do the opposite of what you see. So if we are moving from the left side of the equal sign to the right side, I need to undo what's being done. So for example, I have this x just sitting here. I also, just so you guys know, this 7 is the last man standing is how I like to refer to him because he's attached to the variable that we're solving for. So he's actually going to be the last number we're going to move. We're going to move this x first. And to move it to the other side, I have to cancel it out here. I have to actually subtract it from itself so it equals out to 0. So when I do that, I have an x. I'm going to remove it from both sides. I'm going to move it over to the other side, by subtracting it. Because when I do that, x minus x gives me a big old 0, and that's what I want over there. I want that whole term to go away and go to the other side. So I have a 7y below there equals, I know a lot of you are wanting to combine those two numbers right here, but those are not like terms. This term has an x and this one does not. So you're simply just going to keep writing out that problem, negative x plus 21. And now I'm going to look at that 7. Ask yourself, how are these connected? They're connected through multiplication. So you undo multiplication with division. Divide every single term by 7. And when you do that, you get y equals negative 1 over 7x plus 21 divided by 7 is 3. So looking at our problems over here, it looks like the answer should be C. What is the y-intercept of 4x minus y equals negative 2? So very similar problem to the one we just had before. Looking at your answer choices, notice all of them are solved for y. So that could be your clue of, well, I should probably do the same thing. So let's get that y by itself. So I have 4x minus y equals negative 2. Build your wall, and remember when we're going from one side to the other, we need to do the opposite. So right now I see a positive 4x, so I'm going to subtract 4x from both sides. And when I do that, I do get the 0 over here, which is what I'm wanting. I want that negative y all by itself. And then on this right-hand side, I'm just going to write out my two terms exactly like I see them. They're both negative, so make sure both those negative signs are there. And I cannot combine them because they both one has an x and one does not. All right, on the last step, all I need to do is get rid of that negative sign. So divide every single part of the problem by negative 1. And that leaves me with y equals negative 4 divided by negative 1 is a positive 4. And that x just attaches himself to it. Negative 2 divided by negative 1 is also a positive number, and it's positive 2. So that means our answer would be D as in dog. The last one, simplify each expression. So I'm going to use order of operations here, but be very careful because we've got some numbers that have letters and some that do not, and we can only combine like terms. So I'm first going to distribute that negative sign into the problem. So see how that negative is written right out front of that whole entire problem? I'm going to distribute him in through multiplication. So that's a -1 times a +5. That's going to give me a -5. And then a -1 times a -8k. That's going to be +8k. And then over here, a -5 times a +8. That's -40k. And a -5 times a -8 is +40. Now let's go through and combine our like terms. Only those with a k are going to be able to be combined. So right here I've got +8k and -40k. I'm going to combine those, and I notice I have different signs. One is positive, one is negative, and because of that I'm going to subtract the numbers. When I subtract those numbers I get 32, but it's going to be a -32 because 40 is larger. Bring everything else down. -5 minus 32. Oh, that should have been k. I'm sorry. And then plus 40. And then we can combine our last two numbers, which is -5 and a +40. And those also have different signs. One is negative, one's positive. So you actually are going to subtract those. 40 minus 5 is 35. 35 minus 32k. I'm going to go and try to find that up here. Look for a negative in front of the k, and here it is, 35 minus 32k. So my answer would be B in this problem. The other side has 3 questions that if you would like to pause the video right now and try them, you are more than welcome to. Here are the answers. Hopefully you got D, C, and A. If not, look through my work and see if you can find your mistakes. Alrighty. Number 11, solve each equation for the indicated variable. So it wants me to solve for A, and that means I need to get A all alone. So the last man to move is that +2. The first one we're going to move over is that +4. So I've got U equals 4 plus 2A. Draw your wall. Move over that 4. I see a +4 here. The only way to move it is by turning it into a 0, which means to subtract it. So I'm going to subtract 4 from both sides. These are not like terms, so I cannot combine those. On that side, I'm just going to simply have U minus 4 equals, and on the right-hand side, I have 2A. So now I need to get rid of that 2. So ask yourself, what operation is connecting that 2 to that A? And that's multiplication. So how do you undo multiplication? Well, you undo multiplication with division. So I'm going to go through and I'm going to divide every single term by 2. So I have U over 2, which that's just a 1 sitting up there at that very top. So if you get a little confused there, that's just a 1. So that really becomes 1/2 U, and then -4 over 2, well, that's -4 divided by 2, which would give me -2, and that all equals A. So when I go and look up at the top, notice that I don't really have anything that looks like this. So it could be a little confusing at this point because they actually left it at this stage right back here. And you know that because I don't have a 1/2 anywhere and then a minus just a 2. I don't have that 2 all by itself. So look back at this spot and let's rewrite it to where it's just U minus 4 divided by 2, and that would equal A. And if you look up there, you actually do have that one. That's letter choice A. So that's just being able to rework your answer to match one of the questions or one of the answer choices they have. Number 13, graph the solution on a number line. This is an inequality, and the way to solve an inequality is by using your algebra skills. Try to remember this little trick. If I have greater than or less than, it's going to be an open circle. If I have greater than or equal to or less than or equal to, it's going to be a closed-in circle. That may be able to save you on some of the answer choices. So right off the bat, I look and I see I have a greater than sign. So I should have all open circles, and they all are open circles, so I don't have to worry about eliminating any of those options. So let's draw my line to separate both sides and start moving things over. I'm solving for n, so that means that -5 stays until the very end. I've got to move that +3. So I'm going to do so by subtracting it, because that would give me my 0 that I want over here. And that leaves me with -5n is greater than. These are like terms, so I can subtract. 18 minus 3 is 15. I'm now going to divide by a -5. And whenever you divide, you've got to remember to flip that sign. You know PERT's going to ask that question, so you've got to remember to flip that sign. So I get n is less than -3. So when I go to look for my answer choices, I need to make sure that on -3, I have an open circle, and I want all the values that are less than -3. So let's think about it. What's on the left side of -3? A -4, and on the right side is a -2. Take both of those values and plug them into n and see which one makes sense. Is -4 less than -3, or is -2 less than -3? And you got to remember, the smaller the negative number, the larger it actually is. So if we look here, this -4 less than -3, even though you're thinking, wait a second, 4 is larger than 3, in the negative side, it's actually opposite. So this is the correct inequality. The one below it is not. This is not correct. So when we go and look for our shading, we want to make sure that we're shading over that -4. So looking up here, it looks like choice C would have been the right choice. On the left-hand side of the page, or I'm sorry, on the right-hand side of the page, you have 2 more problems if you would like to pause the video and try those problems. That way you can see if it all is sticking. Okay, here you go. Hopefully you got D and D for both of them. If not, look through my work, see if you can find any of the mistakes that you possibly could have made, and hopefully you're able to correct them. Okay, last page. We worked with the evaluating in the video plug and chug. So this does use the strategy of plug and chug. Unfortunately, you won't know that your answer is definitely right or wrong. You just hope that you did the order of operations correctly. So I'm going to first write my order of operations up here, because I'm going to be using that quite often. And that's parentheses, exponents, multiplication, division, adding, and subtracting. Okay, where I see that J, I'm actually going to plug in a -2. So that's -2 minus 3, parentheses, -6. Instead of K, I'm putting in a +3. And now I'm just going to work through order of operations. I have my parentheses. Inside my parentheses, I have that plus sign, which makes me box it in green. If you owe somebody $6, but you found 3 on the ground, you still owe them $3. And that's why that negative sign is there. So keep writing the problem. Do not subtract these numbers. Remember, subtraction is at the very end of PEMDAS. So we would actually have to multiply first before we would subtract. So that -2 is going to be the last thing you actually do on this problem. So now I have multiplication. I have -3 times a -3, which gives me a +9. Bring down your -2. -2 plus 9 is 7. And I know that because I have different signs. I have a negative sign and a positive sign. So that allows me to subtract my numbers. And 9 is larger, so it's a +7. Simplify is very similar to what we just did, except we're going, the numbers are already plugged in, so we don't have to worry about the plugging part. We just have to worry about the chugging part. So I'm putting PEMDAS again so we can follow our order of operations. And he says to start with parentheses, but as you can see, we do not have parentheses in this problem. We do have exponents, however, so that's where I'm going to start, is with the exponent spot. So if I box that, that's 3 squared. That's the same thing as 3 times 3, which is 9. Bring everything else down in the problem, times a -2, minus 1, minus a -5, times a -1. I like putting parentheses whenever we have multiplication. So again, I have multiplication here that I can go ahead and do. And I have multiplication at the very end that I can go ahead and do, that -5 times a -1. So let's go ahead and figure out those multiplications. 9 times -2 is -18. Bring down the rest. And then -5 times -1 is a +5. So that would give me a 5 right there. All I have left is adding and subtracting, actually just subtracting. So we work left to right. -18 minus 1. Both of those are negative, and since both of those are negative, I'm going to add those numbers and get 19. And that negative sign stays all the way through. So -9 minus 5, I'm sorry, -19 minus 5. That again, I see that subtraction sign, so I know I'm following my green rules. They're both negative, so I'm going to add those numbers and get 24. And that negative sign stays all the way through. So my answer would be B. On the other side, I have 2 additional problems that if you would like, you could pause the video right now and try them and see if you got the right answer. Okay, hopefully for 16 you got 22. Hopefully for 18 you got a -1. If so, give yourself a big round of applause. This video is a little bit harder than the rest of them because this is the real math, and unfortunately there aren't any tricks or cheats to be able to get these questions for sure right. Thank you so much for watching this video, and good luck on the PERT.